about bats using echolocation to find insects. Um, they use high-pitched sound waves to determine the position of objects. The image below shows a bat and an insect flying in front of it. So, what determines the pitch of the sound wave? So we've got amplitude, if you remember, that's the height of the wave. We've got frequency, that's the number of waves in a second, and we've got speed, how fast it goes. So the pitch is going to be frequency. It doesn't ask about that, but the wave is so high that actually we wouldn't be able to hear it. So the bat is actually using ultrasound to catch there, but that's not asked in this question. State the name given to reflected sound waves. So we're looking at echoes for that. So far, both questions are relatively simple. This is where it gets a little bit trickier. The bat emits a sound wave with a frequency of 250 kilohertz. And I just want to highlight that. This is why I ask people to underline the numbers and the units, because suddenly we're talking about some little bit more complicated units and a wavelength of 0.0136 meters. So how are we going to calculate the speed? Well, this is the wave equation. We're going to use the velocity of a wave is the frequency times the wavelength. So our frequency here is not 25 hertz, it's 25 kilohertz. So that's 25,000 hertz. You could also write that, if you remember, kilo is times 10 to the 3. So you could also put it as 25 times 10 to the 3 into your calculator, whichever you are more comfortable doing. Both work. Times 0.0136 meters, which is here, is our wavelength. So you pop those two into your calculator and you get a speed of 340 meters per second. And then you pause for a minute and say, is 340, is that a reasonable speed for sound? Yes, it is. That is the speed of sound in normal temperature air. So 340 meters per second is fine. Sound waves are longitudinal waves. Describe a longitudinal sound wave. So it's not transverse. What it's not is that. It's that strange one where you're getting these bits of the wave squashed together and then spread out and then squashed together again. Okay, so the two key facts you need to know is that the parts that are oscillating, the parts that are vibrating, are moving parallel to the direction of the wave. So the wave's going that way, and the parts that make up the wave are doing that as well. So you need to say that these oscillations, these vibrations, are parallel to the direction of the wave. And that's going to get you 1 mark. This is a 2-mark question. You also need to mention that there are compressions where the bits are squashed together, and over here, refractions. So a compression are where the bits are squashed close to each other, and a rarefaction is where the bits are spread out, and that would get you the 2 marks.